Sir, shall we start, sir?
Yes, you may go ahead.
Yes, sir. Uh, Good evening, all SSI members. Formally welcome all the members today to our talk series, SSI Plenty in 20, talk series 7. Today topic is aerosol, tiny particles, big impacts. It is being given by Dr. Suresh S. Babu, yes, SPL VSSC. So I take this opportunity for I kindly introduce Dr. S. Suresh Babu briefly. So Dr. S. Suresh Babu has received his doctoral degree in physics from University of Kerala based on his research at the SPL VSSC. Currently, he is heading aerosol trace and relative radiative forcing branch of space physics laboratory at VSSC. His area of interest is spaceborne and ground-based observations, as well as theoretical studies of Earth atmosphere for climate science research. He was instrumental in setting up of the national networks of aerosol observation over India under ISRO GPB designed executed thematic field experiments using high-altitude balloons, aircrafts, and research ship, and established aerosol observatories at Himalayas and polar regions. He has authored 212 peer-reviewed papers in internationally reputed journals and edited books with more than 10,000 citations, and his H indexes of about 55. He has several awards and honors to his credit. Few of them are his major awards are Ministry of Earth Science National Award of Excellence in Atmospheric Science and Technology for 2020. He has received ISRO ASI Award for Space Science and Application in 2018, and Shanti Swarup Bharat Nagar Prize in Earth's Atmosphere, Ocean and Planetary Science in 2017. Then Swarna Jayanti Fellowship Award of Department of Science and Technology, Government of India, 2014 and 2019. His major honors are Fellow of Indian Academy of Science, 2021. He is Vice Chair for COSPAR Subcommission A1 on Atmosphere, Meteorology and Climate for 2024 to 2028. He was subject editor for Space and Atmospheric Science, Planetary Science and Remote Science, Current Science. And he has received his Young Associate of Indian Academy of Science for 2007 to 2011. And he's a founder member chosen by INSA Council, Indian National Young Academy of Science, New Delhi, 2015. So over to Suresh Babu, Dr. Suresh Babu.
Thank you, Perumalji and System Society of India for this opportunity. Am I audible?
Yes, sir, you are audible and clear, sir.
Okay. So first I take this opportunity. Yeah, I take this opportunity to thank System Society of India, especially our Jayagumar sir, for giving this opportunity to talk to you on aerosols. Basically, one of these oldest research area at Space Physics Laboratory of VSSC started somewhere in early 80s. I will share the slide first. Yeah, hope it is visible now.
Yes, sir, it is visible, sir.
Yeah. So I'll be talking now in another 20 minutes or so on the aerosols, which are the tiny particles in the atmosphere with big impacts. When we talk about aerosols, the study of aerosols in most of the space agencies have taken up with the remote sensing. With the remote sensing, it is almost in line with the history of remote sensing, because when we talk about the remote sensing of atmosphere or Earth surface or any planetary surface in visible and infrared, initially aerosols are found to be a noise in the signal. Basically, it affects the image quality as well as the data quality. So it was important to have observations of aerosols, along with the remote sensing activities. And later it is found that it has profound impact, which affects the life, especially in climate and uh, in several ways, which we will discuss now. So first, what are these aerosols? Aerosols, as we all know, these are solid or liquid particles, tiny particles suspended in air. I have just shown some images here of different types of aerosols, which can be of different colors, which can be of different composition, which can, like a sulfate, nitrates, organic aerosols. There can be soot aerosols like a carbon, which emits from fossil fuel burning. And there are different types of aerosols. And when it comes to size of the aerosol, it spans from few nanometers to 100 micrometer or so. So its range is quite large in terms of size. So a single technique for its measurements also is very difficult. And not only that, the aerosols, because the size ranges from over a wide range, it interacts with the different wavelengths in the electromagnetic radiation. So it becomes very important in the atmosphere, especially. So, if we talk about the evolution of aerosols, the theoretical understanding was evolved quite in a matured way, probably in 100 years, because most of the theories required for understanding aerosol science is classical in nature. So, with this, if we start, there is a sentence from Bible. We'll start with that. There is a sentence that dust you are and to dust you will return. This is in the context of where the God is talking to Adam, where he is reminding Adam on the human mortality and the transient nature of life. And it is quite true for aerosols also. It's the lifetime of aerosol itself is quite very small in atmosphere, depending on where it locates. So I'll start with another hypothesis which was put forward, probably which was the most accepted answer for the extinction of dinosaurs. We all know that an asteroid had hit the Earth at the end of the Cretaceous period. The impact had thrown so much dust and debris into the air that Earth has blanketed in shadow for an extended period, which is long enough to wipe out the last of the non-bird dinosaurs. Here is one best example of how aerosols can affect the planet. Because when the asteroid hits the Earth, so much of dust is thrown to the atmosphere, which blocks the sunlight for quite a long period. And such a long period of absence of radiation, which will definitely affect the ecosystem, especially the vegetation and all plants. And this is the most accepted hypothesis for that. So this was put forward by two father and son, Luis Walter Alvarez and Walter Alvarez, where Walter Alvarez, the son, is a geologist, and the father was actually an excellent experimental physicist. He was awarded Nobel Prize in Physics in 1968 for his discovery of resonant states in particles physics. But interesting thing is that later he became part of the Manhattan Project with Oppenheimer, and he was, in the early 1940s and 50s, he contributed to in the nuclear weapon design also. So ironically, there is another interesting fact is actually which was put forward by, which was championed by, in fact, by Carl Sagan on nuclear winter, which is also similar to what the Alvarez father and son put forward for the dinosaur, where the nuclear bomb, if it explodes, it is a hypothetical case, of course, because we are yet to face such situation. But if it happens, it also can throw a lot of dust and soot to atmosphere. What nuclear winter says, the hypothesis says, is nuclear winter it's a hypothetical climate effect that could result from a large-scale nuclear war, where widespread firestorms following nuclear explosion inject massive amounts of soot and smoke into the upper atmosphere. So these particles could block significant portion of sunlight, which can drastically cool Earth's surface and disrupt global climate system for years. So the Carl Sagan, who all inspired all of us in probably in our teenagers, we all spent a lot of time with books with Carl Sagan. He was a champion of this idea, and he was all which in the later stage he put forward, means gave a lot of talk that how nuclear war, it is not only the radioactive effects, how it can affect the climate. Say it was actually came up in a classic paper, The Nuclear Winter, by Turco Tu, Ackerman, Pollock, and Carl Sagan, where we can see that the nuclear winter, if it happens, the temperature can reduce by about 50 degrees Celsius from its normal temperature, and which can persist for about 100 days. And the optical depth can be of the order of 5, which will almost block entire radiation which reaches the surface for about 100 days, which can affect the plants also, which means the ecosystem. So these are all some of the big effects of aerosols, which if it happens. So like nuclear winter is a very big thing, but there are several small nuclear bombs are actually we are having in atmosphere, which through our activities, like natural activities like dust storms uh, or the volcanic eruption. And there are so many human activities which produce so much of aerosols into the atmosphere. So it can be through primary aerosols, which is directly eject. There can be through secondary processes also, where the gases can be emitted and gets converted to aerosols. What are its effects? Before going to that, just to have a look at what is the typical values of aerosols. If you look at uh, in China and India, if you look at it, the values are about 80 microgram per meter cube, or in China, it will be close to 50 microgram. The global average is 41 microgram. It is taken from a recent article in Nature, where this aerosols present in the atmosphere can have health effects. And if you look at the number of people died due to this effect, is almost of the order of millions in India and China per year. So that is the kind of health effects it can have. But if you look at why it is so important, the importance of being small, which is actually taken from importance of being earnest from Oscar Wilde, there is a drama. But I put it like this, the importance of being small. If you look at aerosol particles, the smaller particles can stay in the atmosphere for about 400 hours. This is actually a typical case where there is no turbulence, which is a very stable atmosphere. Only the gravity-induced sedimentation only is considered. When smaller particle of the order of 150 nanometer or so can stay for 400 hours at 2-meter altitude, the same altitude, if you take larger particles, how the time reduce. That means smaller particles can stay in the atmosphere for longer time compared to larger particles, and it the order of few days. So if you look at another important graph, which I have shown here, in the atmospheric boundary layer, which is the lowermost layer in the atmosphere, the aerosol lifetime is the order of few days. But if it goes to free troposphere, it can be of the order of few weeks. And in stratosphere, it can be of the order of months. And in the upper stratosphere or lower mesospheric region, it can be of the order of years. This is very important as we go forward when we discuss some of the importance of aerosols. So I told in the beginning, aerosol blocks solar radiation. The process for we call it as through scattering and absorption, and the theory is basically based on the theory put forward by this famous scientist called Gustav Mee, where the aerosols can interact with the radiation through both scattering and absorption. Here, one important point which I would like to say is that the aerosols with the lifetime maximum, higher lifetime in the atmosphere, will very efficiently interact with the radiation. That is the only point which I want to highlight here. So that shows that aerosol has the ability to scatter and absorb radiation very efficiently. The theory is basically based on the Mee scattering theory. So based on this interaction, we can classify aerosols basically into two: aerosols which can scatter radiation and aerosols which can absorb radiation. And scattering leads to cooling and absorption leads to warming in the atmosphere. So, when aerosols present in the atmosphere, it disturbs the planetary energy balance, and the energy balance can be tilted, and this change in balance will be reflected in terms of temperature, the change in temperature. So, to define this change in balance, we normally talk a term, means we use a term called radiative forcing, which is nothing but the change in the net radiative flux at the top of the atmosphere for any planet. So this radiative forcing determines how much temperature it can change. This can be easily calculated provided if you know some of the important parameters related to aerosols, which normally we use satellite remote sensing to retrieve these parameters like aerosol optical depth, to an extent single scattering albedo and so on. So once we know these parameters from either ground-based or satellite observations, we can estimate the radiative forcing. There are different ways through which this radiative forcing mechanism is active. I'll not go to the details because I already talked about the scattering and absorption. So this will explain the how it happens in the atmosphere. This is actually a uh, 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 it's an animation where the aerosol emitted from the forest fire goes up into the atmosphere, where it interacts with the solar radiation, and some of this radiation gets scattered back to space, and some of the radiation gets absorbed in the atmosphere, and it heats the atmosphere. So this heating can stabilize the atmosphere and inhibits the convection and formation of cloud, and at the same time, it add to something like atmospheric warming. We have observed similar situation using high altitude balloon. This is the balloon which was launched from the high altitude balloon facility at Tata Institute of Fundamental Research at the center at Hyderabad. We found that similar layers of aerosols present in the atmosphere, and it disturbed. Along with that, we had temperature measurement. We could see that atmosphere is becoming stable, and we estimated the heating rate due to these aerosol layers and found that these kind of layers present in the atmosphere. This was as an interesting observation which made by SPL and which was cited well in this research by the research community. So in addition to this aerosols produced by from the burning of activities, there can be transport of dust aerosols from other regions to to the Indian region or to global transport. It's basically derived from satellite observations. The left graph is for the winter time when the aerosols are not getting transported, but during the pre-monsoon time, when the wind is favorable, aerosols are getting transported from even the desert regions in Arabia to Indian region. So similar effects happens in other part of the world also, where the Saharan dust from Africa is getting transported to the Amazon region, where it affects the Amazon ecosystem. Basically, the Amazon forest is fed by the Saharan dust. It was not known before satellite era. With the advent of in the last 20 years, there were several satellites were put for dedicated for aerosols were launched. Is like Modis from Modis and Miser and Calypso, and where Calypso is a spaceborne lidar, which could derive the dust transport. It means globally. So they could easily could calculate what is the amount of dust getting transported, and it has revealed one important thing that by geoengineering, if we change the Saharan region by either through fertilization or through irrigation, if you change the Saharan region, it affects the Amazon forest. So these are, and the pathway is aerosols, basically the dust aerosol getting transported. So we could, over the Indian region, we could also derive the aerosols at a different altitude. And we found that aerosols getting transported up in the atmosphere up to 5 to 6 kilometers, where not only the dust, there are dust mixed with the black carbon also. Black carbon is basically the aerosol which absorbs radiation, which is black in color, which normally comes out of all the burning activities. This also getting, so this is actually a combination of ground-based satellite data is used to derive this kind of clouds, and these aerosols are getting transported to Himalayan region, where the impact is quite very important. Here, the importance is here the aerosols, deposition of absorbing aerosols on Himalayas can reduce the surface albedo of snow. Means if the albedo of snow surface reduces, it absorbs more radiation and which can lead to melting. So the SPL research has found out that the snow albedo reduction in Himalayan region, it not only increase the snow melting, it can increase the surface temperature by about 1.33 Kelvin or so. It's a quite significant. So it can lead to Himalayan warming. So this is very important process. We used to get a lot of parliament questions on this aspect to SPL, and we used to give scientific inputs to answer those parliament questions, because it affects the hydrological cycle in the Indo-Gangetic plain, which is a large number of Indian population lives in the Indo-Gangetic plain. So it also affects the monsoon. because there is a hypothesis called elevated heat pump hypothesis, where aerosols at a higher altitude will affect the monsoon circulation, and it can lead to early onset of monsoon, and the real active phase of monsoon will be affected, and the hydrological cycle over the Indian region can be affected. So there are reports on the effect of aerosols on the intensification of cyclone. And another thing is actually on the tropical expansion, where the tropical belt can be expanded and lead to desertification. And this also can be initiated through the presence of aerosols. So understanding aerosols is very important, and one of the best way to understand is through spaceborne observations. Now, coming to an interesting area, actually, how aerosols are produced when they through rocket launches. This is a very recent study published in 2022, and it appeared in Earth's Future. They have considered in 2019 about 103 launches spread all over the world, most of the launch stations, and they considered the fuel used and its emission factors, and arrived at some interesting numbers. Using the ghost cams, there is a atmospheric model called ghost cam. They use the ghost cam model to simulate the emissions, also use by constraining with this information on the launch. They found that there are large number of black carbon is getting emitted along with like water vapor. And here they have considered not only the launch, the re-entries also, like a satellite re-entry to the upper atmosphere and how it perturbs the atmosphere. For me, the interesting thing was the right graph, where they could estimate the aerosols emitted to different altitude. And we can see that significant amount of aerosols emitted to higher altitude in the stratosphere and upper atmosphere, the up to 50, 60 kilometers. And I have shown in the beginning that at those altitude, aerosol lifetime is the order of months to years. So interestingly, at present, if you look at the effect in terms of radiative forcing, it is only in milliwatts per meter square. But as we all know, with more launches in future, after maybe 10 or 20 or 30 years, this milliwatts per meter square can be quite significant. It can increase. So it is very important to have more green fuel to protect our Earth. So this was an interesting study. In the recent time, there are several such scientific studies all over the world which focus on how the rocket emissions also affect climate. Now, coming to another interesting aspect is actually the atmospheric cooling during the volcanic eruption. When there is in 1991, there was a big volcanic eruption which reduces the solar radiation, because it spread a lot of aerosols into the atmosphere, especially to the stratosphere, and reduces the surface reaching solar radiation and leads to reduction in temperature. So these kind of ideas is actually was used by even climate, those who don't support climate change, and they talked about the geoengineering aspects, that by putting aerosols. I will come to that. Before that, there is another interesting thing, how aerosols are helping us. We all know that if there are no aerosols in the atmosphere, the warming in the atmosphere can be of the order of 1.5 degrees Celsius. But the cooling due to aerosols are actually controlling the warming up to around 1.1 degrees Celsius. That means aerosol has some kind of positive effects also at present. But whether this can be taken up as can be used for controlling the climate, that is what is called the geoengineering, where some of the Western world climate negators, or those who don't believe in climate, they say that if we inject large amount of aerosols to atmosphere, especially the stratosphere, it can reduce the albedo, global albedo, and by controlling, by increasing the albedo, not decreasing, by increasing the global albedo, and by control the global warming. But I'm not a supporter to that, because we have an experience of Venus experience, where Venus is incredibly hot because of the presence of carbon dioxide in the atmosphere of Venus. We all know that almost 96.5% of the atmosphere of Venus is carbon dioxide, but there is large amount of sulfate aerosols also present. But we know that it is the Venus clouds are mainly composed of sulfuric acid droplets, and it should reflect sunlight back to space and lead to a cooling in the Venus atmosphere, which is not true because of the presence of CO2. So, which shows that this the idea of putting sulfate aerosols to for geoengineering mechanism may not be a good idea. Which these kind of things which we comes to know from our experience in studying other planets. Like SPL is working on putting payloads for studying aerosols in Venusian atmosphere, basically based on occultation technique. And another area, other outside Earth, in the other our nearest planets where aerosols are quite important is in the Martian. Here, we all know that about the Martian dust. If you look at most of the Martian dust regions are focused along the equatorial, not the near equator region of Mars, and it affects the possibility of using, especially the energy availability for solar panel in the operation of spacecraft. And this is in the Martian energy climate is mainly controlled by the aerosols. And in the solar system, we all know that we have the satellite called for the Saturn satellite called Titan, which has a strong thick atmosphere, where also aerosols play a major role. Where the aerosols in Titan's atmosphere are primarily composed of organic molecules. Basically, it comes out from methane and nitrogen. And the interesting thing is the aerosols in Titan's atmosphere are primarily formed in the upper atmosphere. For when it comes to Mars or Earth and to Venus to an extent, aerosols were formed at the surface and getting transported to higher, basically in Earth and Mars. But when it comes to Titan's atmosphere, aerosols are formed at 500 to 1,200 kilometers, and it gets affects and the other heights it descends. So if you look at the profile, we can see that between 500 to or let's say detached haze layer, we can see, which is the speciality of the Titan, which actually obscure the observation of Titan in basically in visible and near infrared region. And in the plenty in 20 minutes, I took 2-3 minutes extra. I talked a lot, I hope, and I can take up some questions.
Thank you, Dr. Suresh
I'm
Babu,
sure I
for
was
such an
quite
engaging
fast,
session.
but yeah.
So we now have a few minutes to take 1 or 2 questions. So if anyone has any question, feel free to unmute yourself and ask directly. I think Baby Sebastian has put up one question. Is it visible in the chat box? For me, it is not visible.
How will
The question is, how will aerosol reach a higher atmosphere while it is created on Earth? That is the question posted by Baby.
Yeah, it's quite interesting. Aerosols in Earth atmosphere, it produced near the surface, and through convective process, aerosol get transported to the higher in the atmosphere. The most important classic example is we all talk about aerosols over India during winter. This is the time where starting from November to February. This is the winter time with our newspaper will be always filled with a lot of news on the air pollution, basically the particles in the atmosphere along the Indo-Gangetic plain in India, where the aerosols are getting close to confined to the lower atmosphere because the surface temperature will be quite cooler, and hence the aerosols are confined to lower atmosphere. And by March, April time, we don't talk about that. It is what is happening as the sun moves to the northern hemisphere, the surface is getting heated up, and there will be intense heating, which takes the aerosols to higher up in the atmosphere, basically through convection. So this is a classic example how the convective process takes aerosol to higher in the atmosphere. But there is another process called the stratosphere-troposphere exchange, where the tropospheric air gets mixed up with the stratosphere also. So once, especially in the deep convective regions like Indian region, where when the deep convective region, where the aerosols get even transported up into stratosphere. But such effects, the transport is quite small, the transport of aerosol from troposphere to stratosphere. But when large eruptions like volcanic eruptions, when it happens, aerosols can move to stratosphere and stay there for longer period. So basically, there is the one-word answer is through convection.
Okay, thank you, Dr. Suresh Babu. So, on behalf of all of us and
question, Ramsekhar.
Yeah, please.
Sir, good evening, sir. It's a nice lecture, Suresh Babu sir.
I'm
Yeah,
sorry,
I have
I
two
was
questions.
quite
One
fast,
is-
I know.
Yeah, you were telling that actually aerosols can offer a little bit of cooling effect also.
Yes.
One way is the opposite of warming of
Warming.
the weather.
Yeah.
Okay, so,
Yeah.
so what if you have a planned scheme of pumping aerosols to reduce the climate, to mitigate the climate change? One.
Yeah,
Number
that is
two
what I was.
Number two is
Yeah.
a few years back there was a ABC Asian brown cloud phenomena. Whether is it
Correct.
still persistent, and what happened to that ABC?
Yeah, it's both are very interesting questions. One is the Asian brown cloud, which is a political name.
Yeah.
There is never clouds can be brown in that way. Whether in say Asian brown cloud,
Yeah.
that is a political name, because when there are organic aerosols in cloud, whether it is in Asia or Europe or America, it will be brown in color. But the experiment which was conducted for that was by the Western world. So that is why they call it as Asian brown cloud. But the cloud, when it is means when there are large amount of organic aerosols in the atmosphere, there is a brownish coloration, and that's why it is called a brown cloud. But there is nothing to do with Asian in that. So that is their perverted mindset, which made them to call it as Asian brown cloud. Whether it is in Asia or Europe, it will be same. When it comes to the first questions are about the injection of sulfate aerosols in a controlled way. Because the aerosols to stay in the atmosphere, it has to be injected in stratosphere. Of course, that can block radiation, but there is a process called stratosphere-troposphere exchange, wherein the stratosphere air gets mixed with the troposphere in a periodic way. So through that process, this sulfate aerosol can mix with the tropospheric air, where it interacts with the water vapor and form sulfuric acid. So, and that can lead to acid rain in the atmosphere, which will be quite harmful. So the idea of injecting sulfate aerosols to stratosphere is it looks very, it's as a solution, but it's not a good solution.
Yeah, but can't we found some other aerosol which is comfortable for us?
But actually, aerosols to stay in the atmosphere, it should be very small in size. But the best way to control climate change is to reduce CO2.
Okay.
So the same effort, if you put to have good fuels, like to replace fossil fuels, that may be better way. But somehow those who support, because I used to be part of the IPCC meetings from the government side. In couple of meetings I was part of. Most of the discussions were like this on the aerosols and the aerosol pollution, because they don't want to talk about the fossil fuel emissions. And basically, the controlling fossil fuel will affect the economy in the Western world and in our region also. But the best solution is to replace fossil fuel with a more less emitting fuel. And the time and effort which we put to mitigate climate in other way, the same thing can be done in this. It will be more beneficial. That's what I feel. Yeah.
Okay. Thank you.
Thank you, sir.
Okay, still a few more questions there, but due to time constraint, we won't be able to take questions directly right now. However, please feel free to send any question to you have to his email ID directly. So, on behalf of all of us and SSI Trivandrum chapter, I would like to express our sincere gratitude to Dr. Suresh Babu for the enlightening presentation on aerosols, tiny particles, and big impacts. So, we have learned how aerosols, despite their small size, have a profound influence on both Earth's climate and the atmosphere of the other planets like Venus and Mars. The way they interact with solar radiation and affect everything from weather to air quality is truly fascinating. Thank you, Dr. Suresh Babu, for simplifying such a complex topic and sharing your expertise with us so effectively. Your insights have definitely sparked our curiosity and deepened our understanding of this crucial aspect of climate science. A big thanks to everyone for attending, and we look forward to more such engaging sessions. Thank you.
Thank you. Thank you very much.
Thank you.
Thank you, sir.
Thank you.